right, team, we're down by 5. It's the end of the second half. We've got 2-minute warning just went out. Time for the 2-minute drill. All right, so we get the ball in midfield. We need a long pass. What makes a good long pass?
Spiral, coach.
That's right, that's right. The mechanics of a good spiral create gyroscopic stabilization and a turbulent boundary layer. All right, anybody know anything about gyroscopic stabilization? Anybody? All right, let's cut to the tape. So when things spin, they have what's called angular momentum, which means they want to keep spinning the same way. When you try to change the direction that they're spinning, they fight back. That's why Groundskeeper Scott is turning in his chair right now. It also means that if anything tries to make the spinning football wobble, it won't want to. All right, so that's how your Kid Brothers toy top works, and that's how the football flies straighter and farther and truer. All right, so next thing, turbulent boundary layer. Anybody? Anybody? All right, here's how it works. The boundary layer is the air right next to the ball, right here on the surface of the thing, okay, all the way around, right? No turbulence in the boundary layer. The ball's like in the air is like a boat on the water, right? Gets this big wake, okay? The back of this wake, behind the ball here, you got this area where there's not a lot of air, okay? It's like a vacuum back here. Pulls the ball back, okay? With a turbulent boundary layer, right, the air's got more stick-to-itiveness. It clings to the surface better, right? So then your wake wraps around the ball more, right? Just like so. And the difference is you got a lot less area back here, a lot less volume in your wake, and so you got a lot less vacuum, and so your ball flies farther.
Coach, what's this got to do with spirals?
Man, let's cut to the tape.
To simulate a good spiral, we stuck a football in the end of a drill motor and dropped it in a tank of water with reflective dye. As the ball starts spinning, you want to look for the vortices of the turbulent boundary layer. That's the ripples. Climbing up around the football, wrapping it in an envelope so it slips through the water better. It works the same way in air.
All right, so that's why a golf ball is dimpled, that's why shark skin is rough, and that's why our ball flies farther, and that's why we're going to win this game. Because y'all are going to go out there, and you're going to give 110% of the time, and you're going to leave it all on the field.
Coach, isn't 100% the most you can physically give?
Next lesson.